Assalamualaikum warahmatullahi wabarakatuh. I am Nushara binti Mazahar. Thank you for having me today. So for today, I would like to present on the development of the waste polypropylene with the fly ash composite, which is the title of my final year project. Okay, for this project, my supervisor for this project is Dr. Ferdawati binti Rashidi Wong, and my co-supervisor for this project is Dr. Yong Sung Kong. Okay, before we go any further, let's watch a short video that will roughly explain on why we chose the waste polypropylene as the first material in this project. Okay, after we have watched the video before, so it is proved that there is a lot of waste plastic that is not being recycled in this world, and this can cause the environmental pollution and climate change to the world. So, based on the fact there is only 1% of waste polypropylene is being recycled, while the others will be dumped into the landfill or being diminished through the incineration. So this recycling process that occur will affect the polypropylene or the thermal degradation, which affect the intensity structure of the bond that will cause the bond to become more weaker. Okay, thus, in this case, we need the filler to improve the waste polypropylene bond. So in this study, we had chosen fly ash to act as the filler to the waste polypropylene matrix to reduce the thermal degradation of the polymer. Because why we chose the fly ash is because fly ash is also the material that contribute to the pollution to the world. Because waste fly ash will be cast away at the landfills, and the toxic matter can cause health hazard to the human and organic pollution to the environment. So that is the reason on why we chose the waste polypropylene and fly ash as the material in this project. Okay, so this project has become one of the measures that can solve two kinds of material, which is waste polypropylene and fly ash, which can reduce the environmental pollution by recycling this material and develop them into new products. The principal aim of the study is to investigate the utilization of waste polypropylene to produce a new engineering pavement material with the incorporation of fly ash into the waste polypropylene matrix. Okay. Next, we'll talk about the problem statement of this study. So the first one is the waste polypropylene's mechanical and thermal properties are important to produce a composite that is similar to the commercial pavement. And then fillers are required to stabilize the waste polypropylene matrix to enhance the mechanical and thermal properties of the waste polypropylene. And then in this study, we had used fly ash to act as the filler for the composite. And the lastly is the mechanical and thermal properties of the waste polypropylene with the fly ash composite had been investigated. So next, we'll look at the research question of this study. So the first one is, does the incorporation of the fly ash in the waste polypropylene matrix can enhance the mechanical and thermal properties of the composite? Second, does the interaction between the binder, which is the waste polypropylene, and the filler, which is the fly ash, is good without the addition of the coupling agent? Okay, for the second point, this point is highlighted because based on the studies that I done before, most of the researchers only focus on what is the temperature that is needed so that the waste polypropylene and fly ash composite can have an optimum value for the mechanical and thermal properties or characteristic. And then what is the coupling agent that can improve the interfacial addition between the filler and the matrix, but all of the studies only focus on or is really attached to the coupling agent. But in this study, we only focus on these two materials, which is on the waste polypropylene and the fly ash, without the incorporation of the coupling agent. So next is the research objective. So there are two objectives here, which is the first one is to determine the tensile strength, elongation, hardness, and toughness of the waste polypropylene with the fly ash composite through the tensile test. And the second one is to check the thermal characterization of pure polypropylene and waste polypropylene by the thermal gravimetric analysis, which is TGA, and differential scanning calorimetry, which is the DSC. So next is the methodology. So before we proceed to the methodology process, we had look at some of the studies, which is about 7 research articles have been compared, and all cases were chosen due to their similarity in using the waste polypropylene as the matrix of the composite, and then the techniques and the specimens preparation of those cases had been a reference for this project. So next is the flowchart in the development of the waste polypropylene with the fly ash composite. So this flowchart has been divided into two aspects, which is the preparation and the analysis. So from the start, we had collect the waste polypropylene from the Pusat Kita Semula and Pendidikan Zulci in Klang, and we also had collect the fly ash from the Salahuddin Abdul Aziz Shah Power Station in Kapar, Selangor. And then after we had collect the waste polypropylene, we will clean it and shred it into small pieces by using the jaw crusher. The small pieces waste polypropylene is about 3 centimeter in size. Okay, then after we had shredded into smaller sizes, we will mix it with the fly ash by using the twin screw extruder machine at 200 degrees Celsius in temperature at a speed of 60 rpm. Then after we get the extrusion product, we will compress it by using the hot press at 200 degrees Celsius for 5 minutes. And then after we had get the composite, we will run some tests to them, which is the mechanical testing, which is the tensile test according to the ASTM D638 type 1. And then for the thermal testing, unfortunately, we only analyze the TGA and the SC analysis on the waste polypropylene and the pure polypropylene, because we does not have enough time to run the analysis on the waste polypropylene and fly ash composite. And then after we have run those tests, we will analyze and collect. We will collect and analyze the data so that we will get the optimum or the best result based on the test that we have done. So next is the composite preparation. So for the mixing process, we have the waste polypropylene and fly ash are mixed in the twin screw extruder at a ratio of 100 to 0 and to 80 to 20. The machine runs at a speed of 60 rpm with 200 degrees Celsius in temperature. So for the first sample, we had used the 300 grams of the mixture, but for the second sample until the fifth sample, we only use about 200 grams of mixture because we want to save the amount of the mixture for another purpose. So the table show the composition of each composite that we have made. So this is the product that being produced from the extrusion process by the TST machine. So the mixture that had been extruded into a long noodle shape. So from the left side, we have the 100% of the waste polypropylene, followed with the addition of the 5% of fly ash, and then with the addition of the 10% of fly ash, and the fourth sample is with the addition of the 15% of fly ash, and the last sample is with the addition of the 20% of fly ash. Okay, as the weight of the content of the fly ash increases, the long noodle will become more brittle and darker. Okay, so for the compression process, after we get the long noodle shape from the extrusion process. We'll cut it into small pieces, and only 60 grams of each composite will be used to be pressed by the hot press machine for 5 minutes under the pressure of 200 bars at 200 degrees Celsius in temperature. And then the mixture is put into a square mold with a thickness of 3 millimeter. The size of the mold is shown on the figure on the slide. Okay, so the size of the mold is about 15 centimeter in height and 15 centimeter in length with 3 millimeter in thickness. So the figures show the square mold that we had used to produce the composite, and at the center is the small long little cut at the center of the mold. So and then testing. So we had done tensile testing on all of the composite. So this tensile testing had been done based on the ASTM D638, which is the tensile testing for the polymers, and the reference for the tensile testing for this composite is type 1, because the requirement needed to use the type 1 is matched with the composite that we had prepared. Okay, to use the type 1 as a reference, the composite or the polymer must be a rigid polymer, and the thickness of the composite must be less than 7 millimeter. So this requirement had matched our composite, because polypropylene is a rigid material and the composite thickness is 3 millimeter. So here the figure shows the 100% of the waste polypropylene composite in a dot bone shape, which is according to the type 1 of the ASTM D638. And the right figure shows the 80% of waste polypropylene with the addition of 20% of fly ash. So the higher the content of fly ash, the darker the composite will be. And then we also had done the thermal analysis or thermal testing, which is the TGA and the SC analysis. But both of these tests only being applied on the waste polypropylene and the pure polypropylene, because we does not have enough time to run the analysis on the waste polypropylene with the fly ash composite. So the TGA had been done to measure the weight shift that happens when the sample is heated at a constant rate to determine the material's thermal stability and its fraction of volatile components, while the DSC had been done to measure the sample's physical properties change along with the temperature against time. So now we'll look into the result that we had gained from the test that we had run before. So okay, this is a result that is based on the tensile test. So the first one is the yield strength. So the yield strength decreases as the weight content of the fly ash increases. With the addition of the feeder to the matrix, the cross-section of the sample supporting the load was reduced, which have resulted in a drop in yield stress. Okay, when we look at the table here, the minimum value between the 0% of the fly ash and the 5% of the fly ash is not have a significant difference, because it may due to the size of the fly ash. Okay, based on the other studies that we had done, that had been done by the other researchers, state that the size of the fly ash also can be a factor on the minimum or on the decreases of the yield strength, because if the size of the fly ash is big, there will be an agglomeration between in the matrix of the composite. So we does not observe the size of the fly ash that we use. So that might be the reason on why the yield strength of the composite is kept decreases as the weight content of the fly ash increases. And then the Young modulus. So the modulus of the composite increases as the weight content of the fly ash increases. This might show that the ductility of the composite increases. And then the tensile strength. So as the fly ash increases, the tensile strength decreases. It is opposite with the Young modulus. and then this might be driven by the particles detaching from the matrix before yielding due to the poor interfacial addition, such as the fly ash agglomeration in the waste polypropylene matrix. So that is why I said before that maybe the size of the fly ash is the main reason which can be said that the size of the fly ash is big. So that is why the incorporation of the fly ash into the waste polypropylene matrix can cause agglomeration. And this will cause the bond between the filler and the matrix is not good. It's not easily to be done. So elongation at break. The elongation at break decreases as the weight content of the fly ash increases. This might happen due to the interference of filler in the mobility or deformability of the matrix. This interference is created through the physical interaction and immobilization of the polymer matrix by mechanical restraints, thereby reducing the elongation at break. So next is the breaking strength. The higher the weight content of the fly ash, the higher the value of the breaking strength of the composite. And then the tensile toughness. So this tensile toughness has been obtained from the area under the tensile stress strain curve. And then the inclusion of a fly ash enhanced the rigidity of the composite. This significant increase in fly ash filled composite demonstrating the effective stress transfer of matrix to filler during the mechanical loading curve. Okay, so result based on the thermal test. Okay, for the TGA analysis, there is some improvement in the degradation temperature of the waste polypropylene to the pure polypropylene. The absence of the carbonaceous residue at the end of the degradation process shows that the thermal degradation process indicates the pure polypropylene, and waste polypropylene appears to be one-step reaction represented by the single peak. This can be attributed to the radical randomization mechanism of the polypropylene thermal degradation, which is typical for polyolefin. So if we look at the graph here that had been obtained from the TGA analysis, okay, there is only one-step degradation of weight loss for the pure polypropylene and the waste polypropylene, and the value of the weight loss is quite similar. So this has shown that in the waste polypropylene, there is not much other contaminants or other material in the waste polypropylene. So that is why the value is quite the same with the pure polypropylene. Then the SC analysis. So the SC reveals that the thermal properties of the composite material, the degree of crystallinity and the melting behavior are essential characteristics closely related to the mechanical performance of the material and their processability. So the table shows the heating rate, the onset melting temperature, the melting temperature and melting enthalpy for both of the material, which is the waste polypropylene and the pure polypropylene, in the cooling phase and melting and heating phase. So unfortunately, we cannot calculate the degree of crystallinity because based on the formula, the degree of crystallinity for both material is really high, which is above 100%. So the other researchers said that it is impossible for the that is why we does not include the result or the value of the degree of crystallinity in this table. So this is the result that we have obtained from the DSC analysis for the pure polypropylene and the waste polypropylene. So for the upper line, it is indicate the heating phase for the analysis, and the below or the below line indicates the cooling phase during the analysis. So the significance of both. This project has become one of the measures to solve two kinds of waste material, which is polypropylene and fly ash, which can reduce the environmental pollution by recycling this material to produce a new engineering product. And this waste material can be used as a replacement for reducing cost of construction materials. So for the conclusion, this work was intended to evaluate the possibility of using two waste material as a composite for some practical application, such as the pavement, finding the best proportion between waste polypropylene and fly ash for integration by compounding in engineering application was the main aim of the study. So the incorporation of fly ash into waste polypropylene led to stiffer, more brittle and weaker materials as the result that we mentioned before. The higher the content of the fly ash, the lower the tensile strength of the composite. However, it was found that the modulus of the composite increases as the fly ash content increases. The fly ash and waste polypropylene can be utilized to produce a new porous composite material. Thus, the study indicates that the waste fly ash, especially, can be a promising potential to be developed as filler in the polymer industry, but with a coupling agent in those mixed material, because the coupling agent will help um, the filler to easily bond with the matrix or with the polymer. So these are some activity that we had done during the semester, which is we had collect the waste polypropylene from the guitar Smula and the Zuchi in Klang. And then this is me handling the TSU machine. This is the GA analysis, and this is the tensile test that we had done for the 100% of waste polypropylene. So that's it. Thank you for your time and consideration. If there is any question or requirement, you may contact me via the email, which is sharamazahar.13@gmail.com. Thank you. And Assalamualaikum.